In the previous section, we discussed how to find the projection of A on B, and we actually found that it can be the projection of A on B can be found using dot product, scalar product, which is essentially just CF. So this is what we learned. All right, CF, this vector, can be found by this formula A dot B hat times B hat. It is essentially the projection of A on B. Now, what if you want to find this length CF? That means just the length, the magnitude of this vector. What is it called? This is actually called the length of projection of A on B. Length of projection of A on B. How to find it? Let me give you a simple example. What if what if CF is, say, 2.5, 1 over root 2, 1 over root 2, 0. Now I deliberately choose 1 over root 2, 1 over root 2, 0 because 1 over root 2, 1 over root 2, 0 is a unit vector. So suppose this dot product eventually turn out to be 2.5. All right. Now, is it obvious to all of us that actually CF, the length CF is just 2.5? Because it is essentially just taking the magnitude of this vector, taking the magnitude of this vector. The magnitude of this vector must be 1 because it's a unit vector. B hat is a unit vector. Therefore, it's just taking the absolute value of this 2.5 is 2.5. So I'm going to show the result. It is essentially taking this, the magnitude of this, absolute value of this. Now, why absolute value? Because suppose this one is a negative number. Then can I say that the length is negative? Of course not. It is actually just absolute value of 2.5, which is still 2.5. Right? That explains why it must take an absolute value. So many people are confused why this one is a bracket, why this one is an absolute. I think it's quite clear. So in other words, this is known as the length of projection. So there's only one difference. The length of projection is basically a scalar. The projection is a vector, which is actually CF vector. There's something that I want to discuss also. The third thing is this. What if I have all these vectors? I want to find the vector FA, the vector FA here, this one. The vector FA has no shortcut. In order to find FA, it's very simple. I can use FA is actually CA minus CF. Do I know CA? Of course, CA I know, it is vector A. Do I know CF? Of course I know, CF is here. So the result is given quite simply. FA is just A minus CF. Now there's a special name to this. Why? Because if you take a look at this vector A here, if you study physics, you would appreciate that this A can be resolved into two components. One component is parallel to CF, the other component is perpendicular to CF. So A is made up of this vector plus this vector. I repeat one more time. A is made up of this vector plus this vector. So the FA actually is the component of A that is perpendicular to B. Correct? The component of A that's perpendicular to B. The component of A that's parallel to B is actually CF. Correct? Yeah. So I just wanted to summarize everything, and this diagram is extremely useful. Keep it and it will benefit you. That's that.